Let's solve this 1 mark GATE ECE 1998 question. Before solving this, let me teach you a basic concept. So the potential at this point is VA, the potential at this point is VB, and the voltage across resistor R is VR. Since the current is flowing in this direction, for resistor the current will always enter the positive terminal. So this is the diagram. Now I need to know the value of VR and I. Okay, this circuit can be redrawn into wherever your node is there, you just need to connect positive terminal to it. So this will become as this. These both circuits are same. Okay, now let's apply KVL here. So the statement of KVL is the algebraic sum of voltages across all the elements in a closed loop is equal to 0. This is VA and this is VB. How we apply KVL? We move in this direction, we jump and we look back. So I see a voltage VA, positive voltage. Again we jump and we look back, I see a negative VR voltage. Again we jump and we look back, I see a negative VB voltage which is equal to 0. So VR is equal to VA minus VB. And now current I is equal to VR by R. This is Ohm's law. And VR is equal to VA minus VB. Therefore VA minus VB by R is equal to I. Now what if this is VA, this is R and this is ground? Then what is the value of I? Since this value, the voltage here is 0, VA minus 0 by R is equal to I. Therefore I is equal to VA by R. Okay, now let's see what is nodal analysis. The name itself suggests that we need to do something, some operation at the node. So based on the basic topics, what operations do we perform at a node? Okay, do you remember anything? We perform KCL, yes or not? So KCL states that the algebraic sum of incoming currents is equal to algebraic sum of outgoing currents. I1 plus I2 is equal to I3 plus I4. Now I want to apply nodal analysis at this node. Okay, so let me write the currents I1, I2, I3. And why I pointed all the currents outward? Since I don't know the direction of currents, I assumed all the currents flow out of the node A. Later while solving, if we encounter the values of I as negative, then we just need to reverse the direction of arrow. Okay, now I1 plus I nodal at node A, small a. I1 plus I2 plus I3 is equal to 0. If you see in the diagram, I3 and 3 amperes are in opposite direction, therefore I3 is equal to minus 3 amperes. I1 is equal to VA minus 1 by 2. from this formula plus VA by 2. We have seen this formula, that is what we have done. Since VB is at 0 volt, we have kept VA by 2, minus 3 is equal to 0. If we solve this, 2VA minus 1 minus 6 is equal to 0, VA is equal to 3.5 volts. Okay, so the nodal is basically we are applying KCL at node, and then we are using Ohm's law to get the values of current. Okay, so nodal is equal to KCL plus Ohm's law. There is another 1 mark question in GATE ECE 1998. The nodal method of circuit analysis is based on the nodal analysis of the nodal method of circuit analysis is based on. So the answer is KCL plus Ohm's law. And talking about the traps, this is just very basic circuit diagram for using nodal analysis. Direct application of nodal analysis, no traps are there in this problem. So now the very important question, why we are using nodal analysis at any particular node. So the motto behind this is to find the nodal voltage. If we apply nodal analysis at this particular point, after solving the equations, we will get this nodal voltage. Okay, thank you.